looking at question 1 here, and the key thing about this is we have what we have is a prism. This log is a prism because it has the same cross section all the way through, and for any prism you can look this one up in the formula sheet, but it's the area of one end times by the length. I think it might say AH in the formula sheet for height or length. So what we need to do is find this sector area, and this angle on the on this one is going to be 360 minus 50, so we have an angle there of 310 degrees. Now we also need the formula for area of a sector, and that is the angle out of 360 times pi r squared. It's basically just the formula for area of a circle, and then you do the fraction of the circle using the angle. So 310 over 360 times pi times the radius squared, and here the radius is 8.4 centimeters. So we would do that to find the area of the sector, then multiply by the length or the height, which is this one here. Now this is a bit sneaky because this is in meters and our radius was in centimeters. So let's convert the meters to centimeters. I could do it the other way around and convert the centimeters to meters, but I think we'll stick with centimeters. And so that would be the calculation for this one. And I think the answer was 45811.96 centimeters cubed for a volume. Must put the unit for volume. All right, question number 2. This is a little bit of a tricky one because we're given just the coordinates of points A and point M here. And point A is at -9, -2. And point M is at -3, 2. I would always look to start drawing diagrams. No matter what method you're using, if you've got paper in front of you, get drawing. Start to picture what's going on. Now the gradient, we'll use the gradient formula here, which is y2 minus y1 over x2 minus x1. That's in the formula sheet. And we'll label these ones up. There's my first x coordinate and my first y coordinate. There's my second x coordinate and my second y coordinate. Be very careful. So many people made a mistake with the negatives here. So y2 is going to be 2. Then I'm taking away y1, and y1 is -2, so I'm taking away -2. Put brackets around any negatives just to remind yourself that there is a minus and minus here. On the bottom there, x2 is -3 and x1 is -9, so we've got to take away again, take away a negative. There's negatives all over the place here, and a lot of people messed that one up. So 2 minus -2 is 4. 3 minus -9, that's like 3 plus 9, which is 6. And 4 up over 6 is the same as 2/3. So the gradient is 2/3. All right, now we've got a tricky one. We've got M is the midpoint of this line. Now, we could use the midpoint formula here, but we'd have to work backwards because we've got the midpoint and we're trying to find C. So actually, I much prefer to look at this visually and say, well, if that's the midpoint, then this distance along here, I've got to go that distance again. So from -9 to 3, I've kind of gone along 6, and from -2 to 2, I've gone up 4. So I've got to do the same again. Go along another 6 and go up another 4. So from -3, I add 6 along the x-axis, and I get to 3. And then from 2, I'm going up another 4, so I get 6. I think that's the easiest way to do it, but yeah, you could work backwards from the midpoint formula. This is just one way to do it. Part C, perpendicular. Now, the thing we know about perpendicular lines is they have, the gradient is the negative reciprocal. Or you can say that the first gradient times the second gradient is -1.